Not really, but sorry, I can't stop. I can't stop. Oh yeah, I need to collect. All right, so type 1, profit/revenue types questions. Okay. You will, from now on, for the types 1 to 3, you need to create a table. Okay. You need to create a table. I will today kind of model that for you, but you should be able to do that yourselves as well. Okay. Some keywords here. This is on page 53. Whenever you see something related to profit, revenue, items sold, or number of rentals, or anything like that, when you're basically trying to make money, this is going to be where you're at. This is going to be your type. Make a table with 3 entries like this. So this is the cost or price per item. Okay. And this would be the number of items, just to be clear, number of items. And the profit, right? The profit that you make is by taking the cost per item, multiplying it by the number of items. That's why it's stated this way. Okay. This last column is always L2 or our Y variable. Okay, this last one is always going to be our L2 for sure. Okay. Whether we put cost or the number of items into L1, that will depend on the question. That will depend on the question. I'll show you how we discern that in a bit. Number 2, enter either cost or items into L1 and then profit into L2. Right? So you'll put either one of these into L1 and then profit into L2. Note, what goes into L1 depends on the wording of the question. Right? I'll highlight that part. What goes into L1 depends on the wording of the question. If the question says, hey, come up with the equation that relates the cost and the profit, then obviously cost goes into L1 and the profit goes into L2. If the question wants you to relate the items sold, the number of items sold and the profit, then you put this into L1. But notice that the profit always goes into L2. The product of the two goes into L2. Okay. And I'll tell you that the curves will be similar, but they will look different, right? They'll both be parabolas, but they will look different. Another thing I will tell you right off the bat, we're so used to L1, L2. So a lot of students put this into L1 and then this into L2. You're going to get a linear equation. Right? When you perform your regression, A is going to be 0. You know something is wrong when that happens. If you have a line, no matter how far you open your window, you did something wrong. It's most likely that you forgot to put this into your L2. All right? That's the most common error that I see. Third, perform your regression using quadreg. We've done that already. Make sure that your resulting equation does not have A is equal to 0. It would be linear. Okay. Star 1, since L1, L2 are being used, turn on plot 1. That's probably important. Page 53, okay? And then use zoom 9 to help you see the graph. Adjust your window until you see the entire parabola. That's probably also worth highlighting. Zoom 9, that's zoom stat, okay? Maybe let's be specific. Zoom stat, that's what that is referring to. Generally, questions of this type will ask you how the profit can be maximized. How can the profit be maximized? How can we make the most money? This means that you will need to find the vertex, right? You need to find the vertex. If it ever asks you a break-even situation happens at the x-intercepts. They happen at the x-intercepts. That's when you do not make any profit, right? You don't make money, you don't lose money. Break-even happens at the x-intercepts. So why do I have two graphs here? This graph would be if you compared cost versus profit. And this graph is the items sold versus profit. So it will be a little different, right? But if you're comparing cost and profit, this is L1, this is L2, remember that. This is L1, this is L2, it goes with X and Y. So in this case, you'd have your cost here, and your profit would be along the y-axis. Nothing changes for the profit. So dollar amounts. If you were to look at the items sold versus profit, you would go items, right? And then the unit is usually number of, like number of items sold, number of canoe rentals, number of bookings, number of tickets sold. That's what I mean by that. And then you'll compare that to profit. So not dollars on both axes. There's number of, and there's profit is always in money, right? Dollar amounts. And so in this case, when you find the vertex here, in this scenario here, it is actually the cost, right, that will result in the maximum profit. That's what you're finding there. That's this point right here, the vertex. Don't forget that that's the vertex. I think we know, but sometimes I assume, and I shouldn't be assuming, but that's our vertex, right? If you find the vertex here, you're going to find how many items you would have to sell in order to get that max profit. Boom, boom. These are the same. Where's my green highlighter? Right? So this max profit is exactly the same as this max profit. Like the maximum profit doesn't change from one graph to the other. It's just that one will tell you, hey, you should be charging, $20 per ticket to maximize your profit, versus this one will tell you you should be selling 1,000 tickets maybe, right, to make that maximum profit. So they give you slightly different information. Okay. And here we have break even. I should say this one right here and this one right here is the break even. Break even points. Is there anything else that I need to mention here? No, we're good. Always keep on changing my notes. We're good? Okay. 54. Let's go 54 and let's do one. Let's do one of these examples here. Okay. So you read the question. There's a table. How do you know that it's one of the types, Mr. Dirksen? How do you know? No equation given. You're going to have to come up with some sort of, like, some points to come up with the equation, or else you cannot answer anything. Okay, so here we go. A movie theater charges $1.80 per ticket. Lucky, right? It doesn't happen anymore. When I grew up, there was the $2 Tuesdays. Is that still a thing? The cheapies? Still think? Interesting. Inflation isn't affecting that much, I guess. At this price, it sells approximately 400 tickets per day. Right? So charging 180 means that you'll have 400 people buying tickets per day on average. The theater manager has observed, and I'm going to use a different color here because now it's going to tell you when you affect one, what happens to the other. So for every 10-cent increase in the ticket price, there are going to be 40 fewer tickets sold. So when you increase the price, you're going to sell less, right? But there's something, if you're in marketing or if you take business, there's that sweet spot, right? Like if you can keep increasing the price and you might make more money, but there's a point where if you charge too much, you start selling less, right? So you got to watch out for that. So this is your table. This is the template I gave you. You're going to go on your study sheet. Maybe you'll be like, okay, this is type 1, cost, items, profit. Okay, so you definitely should say that this is your profit column. And in this case, we will say ticket price. So this is the cost, which is the ticket price in this case. So you kind of have to adapt it to the situation. And this would be what? Number of items. What would we replace number of items with in this particular case? We're selling tickets, right? So this would be number of tickets. This is items, right? I can put that in brackets on top. And so to get our profit every single time, we would just go price and multiply it by the tickets. That's how you would figure out the price in every scenario. So the first row will be given to you. So if it's at $1.80, then you sell 400 tickets. So that is essentially for the profit, you just have to multiply those two. And we will not answer that just yet. Let's just fill in the rest because I'll show you a little trick. So it says when this increases by 10 cents, so if you go plus 0.1, that would be $1.90. What happens to the tickets? If this goes up, it says we sell 40 fewer tickets, so this is minus 40. Minus 40, so that's 360. And so under this scenario, we would say, well, the profit here would be $1.90 times 360. One more. This happens again. If we were to increase it by another 10 cents, we would now be at $2. But it means that we would sell 40 fewer again. So 40 down, and then we'd go down another 40. That's 320. And again, you guessed it, this would be $2 times 320. So grab your calculators, because we know we're getting to the point where we can perform a regression. I will read the question though here. Read carefully, determine the equation relating the ticket price and the profit. So that means that the ticket price, right, that'll go into L1, and the profit, as always, goes into L2. That's what that is asking you to do. So this is the ticket price right here, and this is the profit. So we're going to enter these two into our L1 and L2. But Mr. Dirksen, what happens to the middle one? Don't worry about it. it's actually going to be part of our equation because it's included in this answer here. So go stat, edit, clear whatever you have there. Mr. Dyson, could I have more than 3 points? Could I keep going like 4 or 5 times? Yeah, you could. Your answer would be the same. Quadratic needs a minimum of 3. So 1.8, enter. 1.9, enter. 2, enter. Go over to L2. Ignore this one. Just over here, 1.8 times, actually go times 400. Enter it exactly the way you see it. 1.8 times 400 and hit enter. And it gives you the answer right there. So that's when I write down 720, right? 1.9 times 360, that's 684. You just have to watch out. Sometimes it doesn't show you the decimals. So you have to be a bit careful with that. So 2 times 320, that's 640. And now you have everything you need. You have your L1 and L2 filled in. Let's go ahead and perform a regression. So we're going to go stat, calc, quadreg. And I really like you showing me which one did you put into L1, which one into L2, either here or right on the chart. It doesn't matter. So let's go ahead, stat. You already did this probably, right? So you don't really need to retype this. Alpha trace, y1, hit enter. There's our equation. Negative 400 x squared plus 1120x. And C is 0. C is most likely always going to be 0, right? Because if you sell nothing, you make nothing, right? Like profit will be 0. So 0, 0 is a point. So this is your quadratic equation. Can I just say something? With profit, you should never have one of the, like, you shouldn't have a quadratic like this. Sometimes students make it, I don't know what happens. I honestly don't know what is being entered, but some students get a positive A, and this just can't be, right? Because you're going to infinity with your profit, right? And it just doesn't make sense, right? So watch out for that. So what I want you to think of right now, this equation shows you a graph where the X value is the price in dollars, and this is your profit, also in dollars. Okay. So you have that always in the back of your head. That's what's happening. Let's graph it and make it show up on our screen, right? So I'm going to go y equals plot 1 is turned on, and I'm just going to go ahead and go zoom 9. Let's see if that helps me. And in this case, it's a terrible zoom. It's not good. It's not as, it shouldn't be like this. So I'm going to go window. I'm going to go -5 for x min. I'm going to also increase my x max at the same time. I'm going to go 10. My y min, I'm going to go -5. That's just my standard. That's just what I do. Just a little bit below. And the y max, how about we go to 1,000 already? Let's see if that works. I'm going to graph it. And my x max is overkill, right? It's a bit overkill. So I'm going to go back. X max, I can probably go down to 5. So that's pretty good. So see these 3 points, that's what it was zooming into. And so that wasn't a really good good screen to have, good window to have. Okay. Now technically I can ask you anything I want. It's just back to what we've done. But there are some differences here. What ticket price would result in the maximum profit? So what ticket price, they're asking you for that, would result in a maximum profit. And then it's also asking you what is the maximum profit. They're asking you essentially for both values of the vertex. So let's go ahead and find our vertex. Second trace, it's a max. They don't have to say maximum, they can just say highest, right? Enter, enter, enter. So we go second, trace, max, and we find 1.4784. I don't want you to be picking a number from your table up there because it has to be exact, okay? So a ticket price of $1.40 would result in the maximum profit of, in this case, exactly $784. So you're answering the question specifically. You're telling me this is the ticket price and this is the profit. And you've done that correctly at that point. Don't just give me the coordinate. That's where it's different. A word problem is different than just the theory that we did, where it's just like find the vertex. Now the vertex means every number means something specific to us. Okay. Pay attention to this one. This is, I'm going to try my best here to make you understand. So it's now asking how many tickets are expected to be sold at the price in C. So if you charge $1.40, how many tickets would you sell? And the easiest way of doing that is by using this formula. I will just say this: tickets not part, not shown in our graph, right? This is not shown in our graph. So we just got to use something else. Use this one. Profit is equal to price times tickets. Remember that from way up there? This is always true. This is always true. And we actually know two things. We know ticket price and we know the profit. So we just insert that here. So 784 is equal to $1.40 times X. I'm just going to call tickets X there. And what do you have to do to get rid of, to isolate X? We divide by, in this case, $1.40. That allows us to turn that into 1. And so X is equal to 784 divided by $1.40, 560. You should expect to sell 560 tickets. If this is ever a decimal, turn it into a whole number. Up or down, I don't care, just make sure it's a whole number. Because it could have been a decimal, in which case you need to round it. And this is the last question for today. What ticket price or prices would give or yield, it's the same word, a profit of $450? Explain why there are two possible prices. So watch this. So we're going to say, okay, well, the profit is given to us. Let's go ahead and find the X value, which would be the ticket price in this case. Second trace, 5. So let's go ahead and do that. I want you to all try this, the 450. Y, so Y2 is 450. Hit graph. And so that is your $450 profit line. It happens here and it happens here, right? It happens twice. So let's write that down first, and then we'll talk about it. Second trace 5. I'm going to find the first one. That is 0.49450. And then, you can see that. Sorry. I need to work on my camera skills. Enter, enter, enter. So that'd be 231,450. And if you're in business, you will study this in more in depth, right? But why is there two instances, right? And so this is the answer here. I will write it down in a bit, but if you charge less, you will be selling more, right? Let me give you this here. This is the 450 line. This would be the cheaper price of 49 cents, and this will be the more expensive price at 231. So you have to decide, would you rather make it cheaper for people, right? Make it cheaper, more accessible, sell more, right? Or would you like to make it more expensive? You would sell less, but still end up with the same profit. So that depends on the, how should I say this, on the motto of the company. What is it that they want? Do they want to like help people out, or do they just want to make money? Because if they just want to make money, they probably want to just charge a little bit more, because they don't have to worry about producing more, right? Or making more of that item. So here is my answer for you. A lower ticket price results in more sales. A higher ticket price will result in fewer sales. But both cases result in the same profit. Right? So both of these cases, either you go cheaper or will end up giving you the same profit. And there's that relationship between price and number sold, right? Okay, that's it. I'm just going to ask you to try 2 questions. 56 and 57. Okay. So where should I put the homework? I'll put it right here. Page 56 to 57. We're not done yet. If you look on the back side of this, we're still graphing it and everything, but that doesn't really change. Like, you know already how to graph and all of that. I will continue with that on Tuesday. But we're going to do all the types next week, okay? So I need you to be on top of this.